important all this stuff was and how it applied directly to my HVAC work. And I was reignited yet once again into my HVAC service work. I started to appreciate and understand it on a whole new dynamic level. And that's what I hope to bring you all to eventually over time. Do we have any questions at this point before we move into something a little bit more easily digestible? For you HVAC guys, all of you actually, but HVAC guys, this number 5 here, energy moves from this place of surplus to a place of deficit. Somebody please tell me how that is important in heating and air conditioning specifically. Water heating applies as well, yes sir.
When it comes to say heating, you're actually transferring BTUs. You're actually adding that into a place where it has less BTUs to generate heat.
Right, exactly. And I like to use the phrase heat moves from a warmer area to a colder area.
Hot to cold.
Moves from warmer to cooler. It's that same basic law, just applied more specifically to one of the specific forms.
And the same thing can apply for cooling, where if you're moving BTU from one place to another.
Exactly. So now we're going to take some of these big rules, and we are going to be repeating this information over and over and over and over and over again. I'm going to ask you, the thing I just talked about, why is it important? It's going to come back to this morning, what we just talked about today. That's why it's important. So if you're sitting here wondering, why the heck is this important? When am I ever going to use this in the field? I'm out here digging a dang trench for a sewer line. How is this important to me? Well, it might not be exactly important in that specific moment, but in 2 days' time, when you've got that all glued up and you're going to run water through it, that's really important. Especially if for some reason it doesn't go the way it's supposed to. What's the first rule? What's the first law of plumbing?
Don't chew your fingernails?
Over here, got it. Wastewater rolls downhill. Right, absolutely.
And I'm not
What's the other one?
You just brought up trenching, and it's very important because
Yeah, great, that sucker, don't you?
well, no, you're pulling spoils out of the trench, and where you're going to stack that the spoils where it doesn't add too much potential energy to the sidewall of the trench where it caves.
It's all the same thing, isn't it? Absolutely. It's the same thing as application of this stuff in motion. All right, I'm going to pass around some handout materials. These are your booklets for today. These are yours to keep. Feel free to take notes in them. You're going to get a collection of these over time, as well as the handouts that we do in our warning sessions. Very good, awesome.
Guys, real quick, I'm going to make sure those handouts for the morning sessions are forwarded to you. I'm going to leave it up to you to print because I know some of you guys will not keep this stuff. So I'm not going to expend company resources, energy, to print them if you're not going to use them.
I'm glad you brought that up, Mark. I wanted to share with you guys something. I'm a little behind when it comes to technology. My cell phone is 10 years old. My computer is about 8 years old. But the other day, I just picked up one of these little critters. An Amazon Fire tablet. I bought it for $50. The reason I got it is, it's like a bomb tab, right? Actually, I started using it. It's pretty kind of cool. This thing, $50. I wanted a new MP3 player, so I actually want. And I started looking around, and I saw this for $50. I was looking at an MP3 player for $60. Duh. Works. Even fits in my pocket, kind of. I wear the right kind of pants. But $50. I can get my email on here. I can hook this up to my Wi-Fi at home. So these emails that Mark's going to forward you, you're going to be getting a bunch of them. Create a file. Get yourself an inexpensive e-reader or something like that, or if you have a laptop, use that. Create a file on that and just keep all of these PDFs that you're going to be getting to refer to later on and study from. How are we doing? Do we need to kill some lights in here, or is that good enough?
You good?
Where's my clicker? Here it is. Okay, so Alan, it is your job to watch this. I will lose it. I'm going to ask you where I put it. When we're working with electricity, the first thing we need to discuss is safety. Electrical energy can be dangerous, just as mechanical energy and heat energy can be dangerous. We need to protect ourselves. How many of you feel a little nervous working with and around electricity? It's okay, don't be shy. We're going to overcome that today. Now, this is the point in which in the presentation when I always say, if you know a certain individual who says something like, that's just 120 volts, I've been hit by 120 volts so many times, it doesn't even bother me anymore, is an unsafe individual, and I suggest you give him a wide distance. He's working.
Oh, it'll wake you up in the morning, I tell you that.
It can be no laughing joke though. 115 volts does not sound like a whole lot, especially if you've been touched by it. And if you've been touched by it and you're talking about it, you weren't touched by it, you were just gently tickled a little bit. It just reached out and said, hee hee hee, coochie coochie coo. That's what it did. It didn't actually touch you. If it wanted to touch you, you would know it. First of order of business is safety glasses. How many of you have safety glasses? Where are they?
Yeah.
You should be at arm's reach at all times. Be able to put them on when you need them. Here's a hot tip about safety glasses. How many of you are like, man, I just can't wait to get my safety glasses on. I love those things. Right.
Well, you got cool.
Get some cool looking safety glasses. More importantly, get some that fit your face and are comfortable to wear. I mean, there's nothing wrong with spending $150 on some totally ASME rated safety glasses. These aren't them, by the way, but man, you're gonna want to wear them. That's important. They don't do you any good up here. They don't do you any good on the dashboard of your truck or hanging from your rearview mirror. This is where they need to be. They need to be on your face, protecting your eyes. And if they're comfortable and if they have good optics, you're going to want to wear them more than likely. So I have a couple extra pairs around too for when these get scratched up and fogged up and yucked up. You got another pair. Otherwise, you won't want to wear them. So you got to have them on. Gloves. Footwear. Clothing. These are all things to think about when you're working with electricity. And we think about them in a specific way. Why do we need safety glasses? We typically think of safety glasses. If you look at a chisel, it says safety glasses required. Hammer, safety glasses required. Hammer drill. Saw. It makes sense because stuff's getting thrown up into the air, right? What are we worried about safety glasses for in working with electricity?
Well, that's like
Stabbing yourself in the eye with a wire? Maybe. What did you guys say?
arc flash?
Arc flash. When you create an arc, accidentally or on purpose, molten metal gets airborne and it goes straight for your face. You do not want that in your eye. That's the main reason why. Same thing for gloves. You are more at risk for burns. I want you to write this down next to this. You are most at risk for burns of an electrical injury. Of all the different types of electrical injuries there are, burns are the most common and the most preventable. Electrical burns. This is why we wear the gloves. So what kind of gloves are you looking for? No, you don't need insulated gloves. We're not concerned with electric shock. We're concerned with burns.
FR, flame retardant.
Anything you would wear that you would use to solder or weld with would be also good for working with electricity. So we're looking at leather as a material. Some of those mechanics wear style gloves. They have a synthetic leather. Those are okay, but they will melt, but for a brief instant they're good for that. Something that you can work with and have good manual dexterity, but is also going to protect you from burns. When we're working with electricity, our fingers, which is probably the most important digit that you have, regardless of what you think is your most important digit, it's these ones. You got to protect them, but they're right there in the danger zone, right next to the source of energy. And if something were to happen, these are the ones that you may be without. We don't want to risk that. instructions on it. And it's also had this little video from a veteran industrial electrician. He's missing an eye, and he was missing these two digits on one of his hands. He described how he was approaching a live service panel without wearing the proper PPE, and all he did was open the door. And it just happened to be that moment when there was a major arc flash explosion, and he lost these fingers and his eye. And it wasn't like, oh, his fingers are over there, grab him and put him on ice and take him to the hospital. No, they were just disapparated. They were vaporized, gone. Burns are what we're worried about. Now, gloves are not going to really protect you against electric shock. It's a whole other different type of injury, but you're more likely to be affected by a burn, so have your gloves on when you're working. For electricians, you're an electrician, yes? No, who's an electrician here? You're an electrician?
Yeah, you're on all
Okay,
the time.
If you talk to an electrician and ask them, how do you stay safe working with electricity? The first thing they'll tell you is turn the power off. Work with power off. Good idea, but when you're troubleshooting and doing service, it's not an option. You're working on live equipment, you have to. And so we have to take measures to protect yourself against these things, and good sturdy leather gloves is one way to do that. Footwear, another thing to think about. No tennis shoes. Shouldn't be wearing tennis shoes on the job anyway, but when you're in the market for some new boots, look for this rating on them. On the toe of your shoe, of your safety shoes, you're going to find different ANSI numbers, and that means they are complying to specific safety standards. One of them is an EH rating, electrical hazard rating. This is a Red Wing boot. How many people are familiar with Red Wings? Yeah, I used to wear Red Wings all the time. Love Red Wings. Expensive, but good boots, right? Red Wing makes hundreds of different models of boot and styles for different purposes, right? Some safety toes, some not, some 6-inch, 9-inch, all these different styles and soles. They only make about half a dozen EH-rated shoes. So when you're shopping for boots, if you're working with electricity, look for an EH-rated shoe. My shoes I'm wearing right now are actually EH-rated. These are King safety shoes. They have an electrical hazard rating. Pretty cool. There's all kinds of different things out there, so pay attention to that when you're looking for boots. The difference is the soles are going to help prevent electricity from passing through your body ground. Now, it doesn't mean you just go grab live wires, but it means is if you accidentally touch one, you're less likely to be injured. And fire-rated clothing, right? The primary source of injury is burns. You can catch your clothes on fire as well. So I do recommend if anyone's working in high energy environments, which is going to be anything over 240 volts AC, to have a fire-rated shirt at the very least that you can put on while you're working in that environment. Some contractors I know about are requiring all their techs to wear FR gear every day, all day. You don't get two chances on that. So some things to think about PPE-wise. What are we definitely going to wear? Safety glasses. We wear good gloves. Now for your meters. Did you bring a meter today? Get your meter out. Take a look at it. Multimeters and Bell multimeter accessories have safety ratings, and you should know what they are. We should know a little bit about using meters safely. There's different categories of meter safety, and it has to do with the level of exposure to risk. What we are most concerned about when exposure to risk is not just the energy potential of the circuit you're working on, but how close is it, physically close, to the power pole. If there is a lightning strike or some other massive energy surge that hits that line somewhere down the line, it is going to go into this building. And if you happen to be testing when it does, will you survive? The closer you are to the service entrance of the power into this building, the more at risk you are. Also depends on what kind of equipment you're working on. So beginning with category 1 down here on the bottom, that has to do with electronics equipment.